Okay, guys, so state the rules, or state the rule that indicates the direction of the force of friction. Well, there's actually two rules. Hopefully you realize this. There are actually two rules. One rule governs static friction, and another governs dot dot kinetic friction. So we've got two rules that govern our two different types of friction and that indicate the direction they go in. And hopefully you guys got a good idea of this when we did the simulator the other day. So when we go back to the simulator, hey, look who this guy is. Alright, so here we are in the simulator. You guys should remember that. And when we apply a force, take a look. The force of friction, when we're talking about static, always opposes the force applied. But once it gets going, the force of friction, whoa, the force of friction doesn't necessarily point in the direction of the force applied because the block can keep moving with no force applied to it at all. And that is because when we go to kinetic friction, friction always opposes velocity. Okay? Hopefully that's a good reminder. Now let's go to this one. This one's pretty quick and easy. Let's do number 2 real quick, and I've got some modified numbers. But what we do have is we have a sled pulling a sled is pulled across a cement sidewalk with constant velocity. So I'm going to draw my sled, and I'm going to draw my sidewalk. And there we go. Now I've got to get into my forces. And all you guys should realize is that the main thing, the real big thing, guys, to get from this, to extract from this part is this right here. 40 Newton sled. What does that mean? Well, when I say I have a 40 Newton sled, I'm saying that this is a force that describes oh, my sled. Well, what force describes a sled? What does force describes you? Well, many of us have different strengths and stuff, but what force could, like, a doctor ask us that would describe us? And the force that describes us, guys, is the force of gravity. So when you see 40 newtons here describing our sled, it's giving us our force of gravity. So we can easily say Fg equals 40 newtons. Okay, so we've got one thing done. Sorry if that looks like 46 to you. It's 40 newtons. And then the next thing it says is this. It's traveling at a constant velocity. So you should know that if we're at a constant velocity, we're at equilibrium. So that means this force is canceled out. This force is canceled out. And what is it canceled out by, guys? Well, it's on a surface. And what's the force of a surface? The normal force. Oh, well, that looks like something. Oh, no. No. All right, so the normal force. So there, we've got that force canceled out. But also, guys, what's the value of the normal force? Here we go. It's going to be 40 newtons. Now, I haven't been giving them net positives and negatives, but for right here, guys, we just realized, the arrows will give us the direction. Okay. Well, now it says this: a horizontal force of 20 newtons is applied, is exerted. What is the coefficient of friction? Well, we know. Let's say this way we have a force applied. Now, I know I probably drew it too big. You should draw your forces to scale, but this is going to be a force applied, and it equals 20 newtons. Now, remember, guys, the big thing is this. Again, we have constant velocity. So if you have constant velocity, you must be at equilibrium. That means there has to be an equal but opposite force acting on our sled. That means that the force that resists the force applied, or possibly even our velocity, is going to be this, the force of friction. Now, what's the value? Well, we're at equilibrium, so all these have to cancel out. So this has to be 20 newtons. And now we can just simply use this formula. F of F equals mu Fn. Mu equals F of F divided by Fn. I just divided by both sides by Fn. And then you're just going to get, in this case, 20 divided by 40 newtons and newtons. Now, once again, you realize the units cancel out. Excellent. Thanks for